In this video, I'm going to explain about the Oracle database server architecture in detail on the basis of my personal Oracle database experience since I'm working as Oracle DBA from last 8 years. So on the basis of my personal experience, I'm going to explain this in detail as well as I'll be covering the interview questions that comes from the Oracle database architecture and what are the scenario based questions and like interviewer may ask you question on L1, L2 and L3 level of resource. And even as a fresher, if you wanted to start your career, yeah, this video will be very helpful for you to understand Oracle database in detail. And also, like interviewer basically asks this question to judge you, like how good you are in Oracle database. So to understanding in detail, first let's understand what is Oracle database. So Oracle database is a combination of control file, data file, and online read log. As you can see, database is a combination of instance plus database files. These are the physical files, and the above one is the instance. It's a combination of SGA system global area plus background process. Like see, SGA is a memory component and background process which is responsible for establishing the connection between the physical files and the memory. And your SGA is a combination of multiple components like share pool, large pool, database buffer cache, Java pool, stream pool, read log buffer. These are the these are the component of SGA. SGA, it's the all these components are defined inside your parameter file, and parameter files are like P file, SP file, even you can say init dot ora file. Inside that, this all instance SGA components are declared into that, like SGA max, SGA target, and share pool size, library cache, large pool size, buffer cache size. These all size are defined inside the parameter file. So let's see one by one each and every component. Like share pool, it has two sub component. One is library cache and another is dictionary cache. Library cache is a set of all the most recently executed SQLs plus PLSQL queries. These are stored inside the library cache. And dictionary cache, it's a combination of Oracle database metadata, basically like objects like index, table, view, all these metadata informations, and even user authentication will also happen to this data dictionary cache only. So next is large pool. Large pool is basically used for Arman and recovery cases, especially when multi-thread server is getting used, or your database is going for restore or recovery. That time, IO operations are happening through large pool. And the next is Java pool. Java pool is getting used for Java related codes and JVM installations. And next is database buffer cache. Database buffer cache is it's a collection of all the data blocks which are retrieved from the data file that are getting stored into the memory for frequent use. And next is stream pool. Stream pool is used for Oracle stream process operations. And the next is read log buffer. Read log buffer is a collection of all the modified changes which are modified from the database buffer cache as a dirty buffer. After that, modified changes are getting stored into on log buffer. So next is your background process. So background processes are two types. One is mandatory background process and the another is optional background process. So mandatory background process are like checkpoint IS, mon, pmon, db writer, log writer. These are mandatory one, and the optional is Rico, archiver, and the other few more. Those are optional one. And control file and data file is the actual data of your organization, which is getting stored into the data file. And even all this data is, after modification also it's getting stored here. And this is the actual data overall. It means an online read log file. This is basically modified data which is used for recovery purpose. And even the read log is also used for instance recovery, like if any immediate crash is happening or something. In that case, your read log is getting used for recovery. So let's see the another scenario, like if you are filing any SQL, then how your database behave, like what exactly happened on your database level. So like as if you go for L1 level interview, they may ask individual components, and they will ask the functioning of these. And even in detailed things also they might ask. Even background process also having multiple things to understand in this, like check pointer. Check pointer is basically responsible for synchronizing your database with the data file and memory. It is making your database consistency. And yeah, and whenever the check pointer is happening, that time the CN number is getting updated to your control file header and data file header to make the database consistency. It is responsible. And this is happening very frequently, like whenever your your buffer cache is getting filled up, whenever your table space is getting offline, whenever space is getting dropped, whenever uh, like there are multiple conditions on that basis check pointer is happening. Asmon is responsible for system Asmon system monitor. And it is basically responsible for instance recovery and temporary segment recoveries. And it is responsible for making the database available to the users. And the next is PMON is responsible for providing the information to the listener. And also it is responsible. PMON is process monitor. It clears all the failed sessions. It is responsible for rollback segment. It is responsible for dead dispatch, restart. And the next is DB writer. DB writer is responsible for writing all the change, modified change data blocks from the DB buffer cache to data file. And it is also called as lazy writer, DB writer, database buff. Yeah, lazy writer. And the next is log writer, LGWR log writer, DB writer, and log writer. These two are responsible for writing the information. So log writer is writing the modified changes from reader log buffer to online reader log. And it is happening in multiple conditions, like your reader log buffer having multiple stages, like unused, current, uh, inactive, active. So these are the different stages of your read log. Unused, like when there is no read log. And the active is when the new one, like whenever this log switch happens. So the current one is current log, where the log switch is not happen, like it is the recent one. And inactive one is when the log switch happen. After that, it's it's getting stored into another log, like log 1, log 2. So log 2 will be considered inactive and log 1 will be considered as active. And the recent one will be current log. Yeah, current stage. So these are the and archival is used for to taking that online read log to archive those modified changes into archive read log file location. And yeah, the next is like whenever any SQL statement is getting fired on the database level, any end user is trying to connect the database. First of all, user process is getting created, and user process is first validating through the listener. Listener will have a host and port information about the database instance. So it will create a server process. There are two type of server process. One is dedicated server process, and the another is shared server process. Dedicated server process will also have a dedicated PGA, program global area, that will store the process information about that dedicated server process. And it will get terminated once the session will get terminated. And the next is dedicated server process is by default. When you do the database installation, your server process will be a dedicated server process. But if you choose a shared server process, that time that time your listener will send that request to the dispatcher, and dispatcher will send that request to all the client requests. That client request will go to the server process, and in that case, in place of PGA, it will be a UGA, user global area. And then that server process will send that request to the instance, and it will go for syntax check, semantics check, and privilege check. And it will validate from the library cache for syntax check and semantic check. And if it finds the same executed SQL over there, then it will take that data from the database buffer cache, and through the server process, yeah, then it will return that output to the client machine and like end user. And if it is not there in the library cache, that executed SQL output, like select query, if we executed, and the output, if it is not there, like same executed SQL is not there, then it will go for dictionary cache for further authentication, for object level authentication, through the metadata of the data dictionary cache. And then it will go for choosing a better execution plan with the help of optimizer. And there is a two thing, it will happen here, like soft parsing and hard parsing. This question you might get in your interview, like what is soft parsing and hard parsing. That you have to tell, like soft parsing is happening in case if that SQL is already there in the library cache, then it will go for soft parsing. And if it is not there, then it will go for choosing a new execution plan on the basis of elapsed timing and cost. It will choose the best execution plan, and then through the optimizer, it will go for hard parsing. And it will it will, through the server process, it will go to the data file on a disk to fetch that required information. And then it will share that information through the server process, will share the information to the database buffer cache. That required data block will get retrieved to the database buffer cache. And then after that, it will return that output to the a client machine, like end user. But in case of DML statements, like select query, it will return the output. But in case of DML, like insert it or update or some like whatever the queries that is doing the changes on the database, then in that case it will happen all this, like it will generate the new execution plan, best execution plan. It will take the output from then it will fetch the data, and it will go to the database buffer cache. And then all the required modification will happen on the query, on the database here. On the block level changes will happen, and then it will become a dirty block. and dirty buffer. Once it will be uh, filled, like your database buffer cache will be filled almost more than one third, then it will start sending that on modified changes to the read log buffer. And then read log buffer, once it will get filled up one third, it will get filled up, or every 3 seconds it will start writing by using uh, a log writer. First log writer will write those changes to the online read log. After that, the same changes db writer will write to the database file. And then there are multiple condition on this, like whenever the commit will happen, that time online read log buffer will write that changes to the through the log writer, it will write to the online read log. And even uncommitted changes will also come to the online read log. But there are multiple conditions on which this will happen, like db log writer will write on every 3 seconds. It will write before db writer writes, it writes whenever the read log will get filled up, or one third it's filled up, or one MB of read log is get filled up. In those conditions, it will write the modified changes, modified data blocks to the online read log buffer. And then from here, frequently, whenever the log switch will happen, sometime it happen by default, or sometime forcefully we need to do that as per the need. And then from here, archiver, optional background process archiver plays a role to archive these online read logs to the archive log. So this is the process that's getting followed in case of DML execution. So the next is, as you can see, SQL statement representation, like the same thing I explained it just now. By this diagram also you can see the same thing, here. SQL statement processing phase, like open phase, bind variable is getting used to nullify more hard perishing. To reduce the more number of hard perishing, we use a bind variable, and then the execute, and then fetch, and then close. So these are the things are happening on the query SQL level. And then if you see a SQL statement parsing exactly what happened, like SQL query is syntax checks, semantics checks are happening, privilege checks is happening. The same thing I have explained in the diagram. Allocate the private SQL area for that, and then existing shared SQL area, it asks yes, execute statement, no, then it goes for hard parsing, and allocate the shared SQL area, and then execute the statement. So that's how it happened. So the same thing next. Why do we need optimizer query to optimize select start from employee where the job is equal to manager? Yeah, how to retrieve these rows? By this you can see how uh, we are doing it here. How to retrieve the rows, possible access path, use the index is a way to improve the performance of the database. If you go for full scan, then it will take more time. If you go with index, it will reduce the total time of execution. So that's how we use to optimize the query. A function of the query optimizer, query, different phases are there, like query transformation, estimator, and plan generator. By this we plan the execution plan. So that's it for this video. I hope this will be helpful for you to understand Oracle database in detail. Thanks for watching till here.